the sections that weren't on the quiz today. So Chris, what were yours?
70 and 86, 14.6.
Good Lord. All right.
Page 931.
Yeah, thank you. So this is 14.6, number 70. Oh yeah, that's right. Now, what's really good in general in mathematics is to be able to look at an equation and know that there is no way in hell you could do that by hand. The unfortunate thing about how we have to teach this is we feed you stuff that will work, but in the real world, it doesn't always work that way. Right? There is no way in hell, truly, to solve this by hand. I don't know if you guys can see that. Is there any way to get x by itself? I mean, if I square root, well, the x is still there. That's not going to be good. If I add 3 and then do the natural log to kill the e, well, then the x will be inside the natural log. There's no way to get x by itself. Are you with me? So if you look next to number 70, it's got a little picture next to it of a graph. And what that means is you graph this thing. Right? Not by hand. Don't go crazy. So in the graphing calculator, if you make this y1 and this y2. Why don't we all try that, all of us who have graphing calculators?
Put that in the y.
Oh, this thing's going to take forever. Yeah, so when you graph this, you should get something that looks very roughly. Where would this guy's asymptote be?
Down 3.
Yeah, down 3. So the asymptote would be there. And the negative on the x, what that does is, if it's on the x, it changes the domain. It changes the left and right. That negative would tell me, if I put a 1 in that one somewhere, now negative 1 would go that way. So what it actually ends up doing is reflecting it around the y-axis. It just changes the positive and negative x around. So normally it would go like this. Now it's going to go like this. Right? So it's going to be, let's see, what's it going to do, Jeff? It's going to go roughly like that. And then your parabola is going to come in and be something
Outside of that.
like that. Maybe it hits here somewhere, I don't know.
Yeah.
So somewhere here this is going to connect. Yeah. So that's going to be your intersection back there. Over here it's got no chance to connect. Right? Yes, sir?
How do you do an E on the graphing calculator?
I'll show you. That's good. Lord. All right.
You didn't talk about exponential regression.
No.
That was on.
Wait. All right, so if you go to y equals, get rid of anything that's in there, your e should be right next to what log? ln. So there's my ln. There's my e.
Yeah.
Right? All these inverses are right next to their function. So if I hit shift ln, I get e to the, and I want e to the negative x. Now be careful. If you don't have the new calculator, you want to put that in parentheses. So I'll go ahead and do it even though I don't have to. E to the negative x minus 3. So there's that side. and then the other side I'll make x squared. And of course, the nice thing, I want you to really realize this, I don't care what level of mathematics you're in, if you have to solve an equation, you can always do this to check your work. Hopefully your teacher makes you do the work. But this one, I can't do the damn thing by hand. So I let y1 be this, y2 be that, and I look for where they meet. That's going to be my answer. I want this line, this curve, to equal that curve. That must be where they meet. Yeah.
Mine says syntax.
Does it say go to?
Yeah.
So hit go to, and it's going to put your cursor right there, isn't it?
Yeah.
Because you use the minus button, you got to use the negative button. Trust me. Hit the negative button. Now, if I graph this, of course, my window's all freaky,
I got you.
but I can see the intersections in there somewhere. Let me do a normal graph. Zoom 6 to get a nice normal window. So there's the exponential, there's the parabola, and there's the answer right there. That's where they meet. I know there's no other answer because this is going to keep going down towards this asymptote. This is going to keep going up, so there's nowhere else it can meet. So how do I find that answer? I should point to the bigger picture with you. How do you find that answer? Yeah, second trace to get to calc. Intersect. It's crazy. Or you just hit number 5. I want you to realize this. It asks you 3 questions. We've gone over this before. If I've only got 2 functions in there, the first question is first curve. When you hit enter, it moves itself to the second curve. And then the third question is guess. So if you just put the cursor on your guess, enter, enter, enter. Because it does the other work for you. Enter. It switches to the next curve. Enter. And I've already got it on top of my guess, so enter. So I get this beautiful number. You guys get that same thing, or?
Yeah.
Okay, everybody looks good? Okay. So that, what's that y value have to do with this equation? The correct answer is not a damn thing. It just happens to be what value these are. I don't care what value they are. I just want to know what x makes them equal. So the x is the answer, negative 1.873, blah, blah, blah. That's the solution to that one. Yes, sir?
Okay, the thing you wanted me to
Yes.
that I had with the calculator,
Mhm.
not finding it, it was, you could do the same thing with number 71 in 14.
Yeah, 14.6, the natural log of 3x.
The log of, natural log of 3x equals 3x minus 8, and then you have to find both points where it meets.
Okay.
So if you plug it in the
So
calculator,
there's a problem that says,
what was it? It was on my math lab where it says find the intercept.
so this is number 71 in the book.
Yeah, I don't remember.
And it looks a lot like the one you're talking about in the math lab, but
There's going to be 2 intercepts.
so if we change this out to be natural log of 3x for one side, and then 3x minus 8.
I found it. It just took a really long time.
Yeah. Yeah, so the weird thing about this, so for logarithms, you have to know the shape. What's wrong with the way this log looks? What's it look like this log does?
It just ends.
It looks like it ends. We know, what does it do?
Keep it going down.
Yeah. I don't think I've one thing I know I haven't done a good enough job this semester, and that's just my fault, is to really, really continue to stress the form of things. Because in pre-calculus, you go over them all again, but you have to know the form of graphs. So exponential like this, logarithm is supposed to be its inverse, so logarithm looks like that. So that piece is what I can't see. So how many answers are there? You might say there's 1.
There's 2.
But there's actually 2. There's another one right around here somewhere.
Yeah, my math lab will make you do 2.
Yeah, beautiful. And I totally agree with it. And this is just a question, really, do you know what this thing looks like? I don't care what the graphic calculator makes it look. So why does it look like it's only 1? Because it gets so close to this axis that I can't see it. So you have to know what the shape is. So if I want to see this answer better, what can I do? So that answer I can get pretty easy. How do I get the answer down here? Use my favorite thing, Zoom box. Just come down here. Enter for one corner. Open it up. Here comes the log someday. Well, there's the
The log's
log.
not gonna come down.
Ooh,
It didn't even.
that's gross.
I told you.
Yeah. So then you zoom even more.
What?
So I know it's somewhere in here. I'm gonna make this thing show up.
It's not gonna show up.
It still won't show up.
It won't show up.
Oh really?
Yeah, you
I'll
can
take
try.
your word for it.
You can even try and trace it. It won't
It
go.
won't.
All right,
It won't
just
go.
stays.
So if you go to second calc, but the thing is, I know the answer's right here somewhere.
Yep.
So what I do is, in fact, right now it's on the log itself. Let's see, where am I? Let me change curves. There we go. So let me put this right where I know the answer should be, which is right next to this axis. That's where the answer should be, because the log gets really close to this axis really quickly. So I know the answer should be right there. And then I just do what I always do. I go enter, enter, enter. There it is. Really tiny. This is 0.0001118, blah, blah, blah. So it's that close to the y-axis. That's why it's really freaky. All right. Yeah, so watch out for that one. Thank you. I didn't know what was going to happen there. Yes, ma'am.
Can you do number 30 on 14.6?
Let's see. Uh, 30, right?
Yeah.
It's not gonna be 6.
I think it's like the same one.
This one?
Yeah.
Yeah, okay. What's the first step on here?
Bring the 9 over.
Yeah. Subtract 4, yeah. Isolate where your variable is. So I got one more step to do that. Yeah, so the 5s just go away. And then I do what to both sides?
Log 'em.
Log, natural log.
Natural log, because I can do exactly the right base here, right? So if I had a 10 here, I would do log base 10.
Now, why can't we do just log?
You can,
Oh, okay.
but ln has a base of e. So the beautiful thing then is ln and e, what do they do?
Cancel each other.
Cancel. So then you just get 4x equals, and what's ln of 1?
The 2 point.
E.
Any log of 1 is 0, because what power does anything need to become 1?
0.
A 0 power. Right? And so x equals
0.
0. Let's check it out. 4 plus 5. What's e to the 0?
1.
So 4 plus 5 times 1, is that equal to 9? Sure, why not? If it isn't, it should be, damn it. It just sounds right. Okay? Is that cool? That was a little weird, because they have a little calculator symbol next to it, and you're like, why the hell?
Yeah,
have
you don't
it
have to.
How did you put it
It's a little evil on the book's part.
Number 86. Same section.
Oh yeah, that's the other problem. Yeah. So this one's synthesis. So you might think it's going to be difficult, but I don't see why this is difficult. What's the first step? What's nice about this problem that you don't have to even use logs?
You can reduce.
Yeah, they're both based on what base?
2.
2. So this is 2 to the
3.
3, and then times the x that's already there. This is 2 to the 4th, and then times the 3x plus 9 that's already there. Right, because you multiply powers when you raise one to the other
They're
one.
the same base, you multiply each other.
Say again?
They're the same bases. So you can multiply them together.
No. That's not why. I mean, 16 itself is 2 to the 4th, right? And what do you do no matter what the hell's going on anywhere else? What do you do with those powers? Multiply them. So it has nothing to do with the fact that I made the same base. It's just the fact that there's a power there and it's being raised to another power. I multiply those powers, period. Property of powers. So I get 2 to the 3x equals 2 to the...
12.
12x plus 36.
So then what must be true? 3x must be... Yep.
That's all.
If you don't like that, you can say I took log base 2 of both sides. What's log base 2 of 2 to a power? They
Cancel.
cancel. Bam, bam. So that equals that. Bam. So just solve that.
That was weird.
Huh? What do you get there?
X equals. So close.
Yeah, you get 9x equals negative 36, so x equals negative 4. So I don't know why the synthesis. That was easy. You guys agree? I mean, do you see what to look for? If you use logs from the beginning, are you wrong? No, you're not wrong. You'll get to the same answer. It's just I don't need to use logs. Why would I?
Hey, could you? No,
Could.
I mean, could you show? Could you?
Could I show you what it would look like?
Yes, please.
Okay. Since you asked so nice. So if I use logs, what log do you want to use?
Natural log.
Hey, look at that. Just like a real math person. So natural log. Get lazy like the rest. So, and the reason we do that is so we can
Bring the X's down.
bring the x down. Remember, this is where you got to be a little careful. Divide by ln 8, stupid. Don't do that.
Divide by the LN16.
Multiply,
That's also not so good.
distribute.
You could, it's not terrible. But you should get used to even distribute. And where are your x's since you're trying to solve for x? What do you want to do with all the x stuff?
All the sides, right?
Get them all together. So just subtract that other x thing.
And subtract it.
Get the x's together. And why did we do that? So we can take the x out. Right, there's really only one x. There's an x in front of all this mess. And then what do I do with all that mess? Divide. And then throw it in the calculator. And believe it or not, that whole ugly thing, if you put this in the calculator, 9 ln 16 over ln 8 minus 3 ln 16, if you put that in the calculator, you will get negative 4. I agree. If they would have made this a 7, we would have had to do all this. There's no other way. By hand, anyway, right? But since I was an 8, I can do it that way. I can make the bases the same, therefore I can make it an easier problem. Just by equating the powers. But if you don't remember that, doing this is not wrong. It's just more places to make mistakes. Right? This one.
Why on the x ln 8 minus 3x ln 16 equals 9 ln 16? Why can't that just become negative 2x ln? Oh, because they're different. Never
There you go. I knew it was going to get there. Yeah, not like terms, so yeah, can't do it.
mind. So, but if they were like terms,
Then you could. If this is ln 8, then it would be negative 2x ln 8. Beautiful. It's crazy how it all comes back, right? It's crazy. It all ties in.
So can you show us the exponential regression?
Where's that at?
Oh gosh, I don't know, it's a problem in homework on my math app, so. See, it's in 14.8.7.
Oh, so I must have...
It was the last question.
Yeah, so that I went too far with the... What I hate about my math lab associated with the book is that sometimes the problems don't match up. So if I'm not careful and look at every single problem, I might assign one that I don't need to. So I'm not going to do that for the general population. We don't need to look at regression. It's part of what you do if you take statistics. So for that problem, I'm just going to make it worth 0.
Well, I
So you just got to remind me, huh?
already did it.
I don't care. I can go in and make the weight 0.
But
You know what I mean?
done it.
If you did you get it right?
Yeah.
All right, then I'll leave yours alone. So there's a problem in my math lab. If you're doing my math lab in section 14.7 that deals with something called exponential regression, we didn't talk about it. So if you want to, send me a quick message and say, hey, can you make that problem worth 0? Because it's freaking me out, and I can do that. Okay? Yeah.
On 64, because they have the same log to the 3, could you just multiply the x minus 4?
Where are we at?
On number 64, on 14.6.
Oh, Since they have the same base, you can log base 3 of the product, yeah. So if I have log base 3 of something plus log base 3 of something, I can do log base 3 of something times something, right? That's the property. I like it. Cool. Yes?
When you try and get negative log out, did you put 9% in 9?
So if you put this in the calculator, let's do it together. So if I put that in the calculator, so I got 9 ln of 16 divided by parentheses. So you make sure that you close this parenthesis here, right? If you don't close this, then everything else is in that first ln, and that's not what you mean. So I hate that. It's like Microsoft Word. Don't guess what I want. I'll put it there if I want to, but I won't. It looks like you're trying to shut. So ln of 8. See how I put a parenthesis here so it knows what the bottom is? Ln of 8 minus 3 ln 16. Close that and then close that for the bottom. There's my negative 4. So make sure you close these, but then also if you have more than one term, you have to put a parenthesis around the whole thing so the calculator knows, oh, that whole thing is on the bottom. If I don't, it'll take this minus thing and put it out here like it's separate. Right? It knows order operations, so we have to put it in there correctly. Why does this expression not need parentheses?
Because we know it.
Because I got the big-ass bar there, right? Is there a big-ass bar option in there? No. So it always needs a parenthesis to tell it what's on the bottom, right? Yes, sir.
So whenever we see something like that, if there's ever an addition or subtraction, like the 3x plus 9 there, just distribute and go from there.
Oh, here.
Yes.
Yeah. Basically, whenever there's more than one term here, you want to distribute and then get your X stuff together. Yep. Cool. Can you believe this is the last week? This is weird. Just want to remind you of that.
Very.
I always felt, even when I was not doing really great in the class, it still kind of felt good that the end was coming. Yes?
So if we get to stats, are they going to expect us to know the exponential rate?
Oh, hell no. No.
Or they're going to teach okay.
Yes.
I just
Yes.
didn't want you to not teach them and teach you.
It's not it's not even part of the curriculum here. It's just I liked it throwing it in here, but it's just a little too much to get into with everything else I had to throw out. So I'll just leave that for anybody who wants to take stats, which is an awesome class, by the way, you should take. How many of you guys have taken 176? How many of you guys have already registered?
I will
Can't
be
until 3 p.m. today.
Okay.
You already have like 5 people in your class.
Yeah.
Oh, I haven't even checked. So it's registration started.
Yesterday.
Okay, all right. Good. So I just need about 15 more, and they won't cancel it.
They
Yay!
won't cancel it. They're already
Yay!
filling up at prior to registration time.
So if you need any help figuring out which teacher to take, I don't know, is anybody in that boat?
You can go to Rate My Professor.
Yeah, it's pretty good.
Yeah, you were rated on Rate. That's the only reason I took you versus the other lady. This summer.
I'll tell you this.
No, I'll
tell you this.
Why. I did too.
I heard about, they told us about Rate My Professor when I was on the East Coast at this college called Virginia Wesleyan College, and the next day you could tell the professors that went in and rated themselves. It was pathetic. So they told us about it, like, oh, really? That exists? Oh, I don't care. And then, everybody was going in there. And I was pointing out, I was like, come on, you wrote that. He's like, essence of the essence, chili pepper. I'm like, come on, dude. That's pretty pathetic.
See, it seems like teachers do that here too.
Yeah, some of them.
Because I was going on, there would be a bunch of terrible reviews, and then, oh my gosh, this teacher's the best, so helpful, and it's the only person that got a good grade.
Like, what do you know? One of my classes, he was like, he messaged him back and was like, what do you guys know? You failed.
Wow. Wow. I'm sure that's helping his case out. That's pretty pathetic. No, I had, trust me, I had somebody in my own department who's no longer here, which tells me the evaluation process works sometimes, that would do that. Yeah, anyway. So let me see, how many guys, anybody taken 120?
What is that?
No.
Why would you take 120? I'm just like
It's transfer level, period. So if you don't need any further math, if you just want to take a transfer level math course, that works. Math 160, you guys taking Math 160?
Yeah.
For you guys?
Yeah, not till like.
Yeah, but you're only teaching in like the middle of the day on Monday, Wednesday, right?
Yeah, I know.
Yeah, because he's teaching every morning.
So if you're taking 160, Brenda's really cool. Brenda Wilmore.
Yeah, so change.
Wait. What time is your class?
What day?